Okay, so we're going to talk about the language of sets. So one main application of sets is constructing relations. So a set is a well-defined collection of distinct objects, and the objects of a set are called members or elements, symbolized by this symbol here that looks like an E, or it kind of looks like a comb or the end of a pitchfork, however you want to look at it. But that's the symbol that means elements. So it means it's an element of a set. If the object is not a member or an element of it, then it's got a line through it saying like, no, that's not true. So elements can be anything. They can be numbers, people, jobs, letters, dogs, cars, food, cards, pets, animals, names, colors, and so on. To represent a set, you can list the element within braces. This would be listing or roster notation where it's in between the curly brackets. So 1, 2, 3, 4 would be set B. The ellipses, which are the 3 dots, they mean that the set of elements continue in the same pattern. So you could have like 1, 2, 3, 4, 5, dot, dot, dot. We know that continues to be 6, 7, 8, 9, 10, and so forth. If we see them before and after, we know that there are numbers before this and after this. So before -2 would be -3 and -4 and -5, but after +2 would be 3, 4, 5, and they would both continue going to your infinities. So we understand that each of those sets contain more elements than what we see listed. Now there's something called the set builder notation. That is where, so like, let's say C is equal to X. There's a line there that means such that, X such that, X is a carnivorous animal. So empty set is a set that contains no elements. It's symbolized by empty set of curly brackets or the 0 with a line through it. So that's when you've had a math teacher tell you don't write your zeros with a line through it because that actually means the empty set. Now, if you put an empty set inside curly brackets, that's no longer an empty set. That is the set that contains the empty set. So do one or the other, but don't do it this way because then you actually have a set that contains the empty set. We also have something called the universal set. It's the set of all the elements under consideration in a given discussion. A cardinal number, which is the number of A, the number of elements in set A, so whatever that is, and it can be finite or it can be infinite. Counting numbers are natural numbers are positive integers. Whole numbers are an integer, so the counting numbers are 1, 2, 3, 4, 5, and so forth. But whole numbers can be the negatives, the 0, and the numbers. And rational numbers are a quotient or fraction of 2 integers, so that's like a fraction, okay? So you might find those terms useful in what we are going to do. So let's do example 1. So let's consider set S. And set S includes spring, summer, fall, and winter. So can we name this set? So what do we think that the set with spring, summer, fall, and winter would be? Well, we could name this the seasons of the year, because those are the seasons that we see in our year. All right, let's look at example 2. We are going to use set notation. So if we look at the set of B is equal to Y such that Y is a color of the American flag. We can also say, for the same purpose here, we could say Texas. They both have the same colors. So American flag, we could also look at another example would be the Texas flag. But if we're looking at the colors of the American flag, and we want to put this just in set notation, we could also state that B would be red, white, or blue. So that would be set builder notation, and that's just set notation. All right, example 3. We are looking at well-defined sets. Not all sets are well-defined. Some are better defined than others, and some are very, very vague. So if we look at part A, we could say that A is equal to X such that X is a mountain over 10,000 feet high. So, is that well defined? Well, it's very specific in the fact that it has to be 10,000 or higher. So there's something that qualifies it. If the mountain is under 10,000 feet, it's not in this set. But it's over 10,000 feet, then it would be in this set. So there is something that you can quantify at 10,000 feet. It's either above it or below it, and you can decide that. So this one is well defined. If we look at part B, so we're going to put well defined, and let's state our, well, we've kind of stated the why. Now, if we look at part B, if we look at X such that X is tall, is that one well defined? So what is tall is my question for you. I can tell you what 10,000 feet is. I can measure that and say, this is 10,000 feet, this is where it's at. But if I say it's tall, what is tall? It kind of depends on your perspective. This is one that is open for interpretation. So I could say that, you know, the door is tall, but someone else might say that the mountain is tall. I could say this building is tall, but someone could say that, you know, the height of a street light is tall. So it just depends on what you think tall is. It's an opinion. So this one is not well defined because it's an opinion. Let's see, we'll put open to interpretation, or opinion. Okay. All right, let's look at set C. If we have C is equal to the set such, or Y, such that Y is a scary movie. Is this one well defined? Well, again, what's scary to you may not be scary to me, but what is scary to me may not be scary to you. I don't like to watch horror movies at all because they're scary. But my husband loves to watch them because he doesn't find them scary like I do. He finds them kind of funny. So, that again is an opinion. So it's not well defined. And why is because it's opinion. Okay? All right. Let's look at example 4. So if we're looking at example 4, and we have M is equal to the set that M such that M is in your math class and also an astronaut. So we're looking to see, does this exist? Can someone in your math class right now also be an astronaut? Well, let's think about this. So an astronaut has to go through astronaut school, but they have to have degrees in science and probably some other like specific in science with astronomy and stuff like that. There's going to have to be a lot of math classes. So can they be in your first year math class and also be an astronaut? Probably not likely. This would be what we call the empty set. That would be an example of the empty set. Okay. All right, let's go to example 5. So for example 5, we are going to use set element notation. So we're going to use either this one or that one, okay? So either the E or the E with a line. And it's more of a curvy E. Looks like a comb that doesn't have very many teeth in it. All right, so part A, we have 3 with our blank, and we have 2, 3, 4, and 5. So we want to know, is number 3 an element of this set or not an element of this set? Well, I can see that 3 is actually in there, so that tells me that this is going to be an element. 3 is an element of this set. Now if I look at B, and I have the singleton set of 5 with a blank, and I have the same set, 2, 3, 4, and 5. Now, is this an element or is it not? So what I want you to notice is the difference here. This is just a 3 and just a 3 is in there. This is a 5 with curly brackets around it. That means it's the singleton set of 5. Is it in there? There is not a 5 surrounded by curly brackets on itself right there, so this would be not an element. 5 is a number, but it's not the same as that there. All right, let's look at Bill Gates with a blank. And we're going to have the set of X such that X is a billionaire. So is this an element? Is Bill Gates a billionaire? Yes, he is. So that means that Bill Gates is an element of this set. He is a billionaire, so he is in the set of billionaires. All right, let's go look at example 6. So we're going to find the cardinal number of a set. So part A, we're going to have M is equal to the set X such that X is the number of months in a year. So remember those cardinal numbers, it's the number of elements in a set. And it can be finite or infinite. So what's the number that is happening? Well, there's 12 numbers, or sorry, 12 numbers. There are 12 months in a year. So our set is finite, and we can say that the number of M is equal to 12. The number of M, because that's our set M, is 12, because there's 12 months in a year. All right, let's look at B. If we have N is equal to 1, 2, 3, dot, dot, dot. This is the set of counting numbers, so it is infinite. So we can say this is the set of counting numbers and that it is infinite. That means it keeps on going to infinity and beyond. All right, little Buzz Lightyear there. So if I look at the empty set has no elements, so that means the number, the cardinal number for the empty set would be equal to 0 because there's nothing in the empty set. Now if I look at a set D, or part D, with set A equal to 2, 4, 6, 8, dot, 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 14. Now the difference between here and here is I have an ending number. So how many numbers are in there? Well, we have 2, 4, 6, 8, 10, 11, and 12. There's 3 numbers and then a 14. So 1, 2, 3, 4, 5, right? So 2, 4, 6, 8, 10, 12. I think I had an 11 in there. 12 and 14. So 8, 10, and 12. There's only 2 between there. So sorry. 2, 4, 6, 8, 10, 12, and 14. We have 1, 2, 3, 4, 5, 6, 7. So that means the number of A is equal to 7. Because we know that this has 10 and 12 in there. They're just not written. They're written with the ellipsis. So that would be how you're finding your counting numbers. Or sorry, not your counting numbers, your cardinal numbers.